about a bus topology yesterday, that what are the possible pros and cons of using a bus topology, and why do we require a bus topology. I told you that why we are discussing this different topology schemes, because our aim is basically to design a LAN, local area network. Because if I say about communication network, right? Can you say what is a communication network? How will you define a communication network? You have already studied different types of networks. Can you say what is a communication network? Vishal Giri, can you say what is a network? Vishal Giri. So Vishal Giri is absent, right? Vivek Kaushal. Vivek Kaushal. Sumit Anand. I'm marking you absent then. Vivek Kaushal, Sumit Anand. Already Vishal Giri has left, so Vishal Giri is absent. Then Saurabh Sinha.
Yes, sir.
What is a network? What do you understand by the term network?
Sir, how different nodes are connected, interconnectivity between different systems in that
Right,
network.
right. A set of nodes interconnected with each other to for exchanging information, right? So when we are saying about a communication network is a set of networks which allows communication, right, through that. So there are many examples that you had seen earlier also, like an ARPANET, okay, uh, X.21. There are many such networks, communication networks exist, ISDN. So many such networks exist, right? Internet. So basically, we can divide. How can we classify communication networks? So we can classify the communication networks either based on the technology used, topology, or transmission media. So these are the three things on the basis of that we can classify a communication network, or we can classify on the basis of a geographical scope. So can you say the difference among local area network, wide area network, and a metropolitan area network? Anyone? Vishal Kisku.
Yes, sir.
Can you say the difference in local area network, wide area network, and metropolitan area network?
Sir, in land, the area is means the area is pretty small. Like, for example, sir, Mesa campus, we can say that it is a land, then an area greater than the local area, we say it wide, and uh, bigger than wide, it is metropolitan, like a state area, like.
So which covers larger area, wide area network or a metropolitan area network? I understood that what you said. I understood that the local area network can cover only few kilometers, right? Like on our campus, we have different LANs, so we cannot extend LANs beyond a particular for a larger distance, right? क्यों नहीं कर सकते हैं? That we will discuss. Yesterday also I had told you that what are the limitations of a bus LAN, that you cannot extend it because there are mechanisms for collision detection and other things which will be which will not be feasible when you extend the length of a network, right? So so why can't we have larger area, larger local area network? That's a separate question. But what you said, that the wide area network and metropolitan area network, so which network is larger, which covers the larger geographical area?
Sir, I think it's wide area.
Yeah, so you said earlier the opposite. Can you say an example of a metropolitan area network?
Sir, like a city means like a Ranchi, sir.
Right. So it covers a city like Ranchi. So the best example of a metropolitan area network is a cable TV network, right? That covers the entire city. So cable TV network is an example of a metropolitan area network, while wide area network means where you will be interconnecting different constituents, right? Like from here you are talking to Africa or Australia, like so different constituents we are interconnecting. So that is basically a wider area network. Can you say the application of local area network? What are the applications of local area network? Abhishek Agarwal, what are the applications of a local area network? See, I told you that ऐसा नहीं है कि आप सोते रहोगे और वो चलेगा. The subject is not like that. So if you do not interact, this will be very boring kind of thing, right? Because it is only about talking. I'm not already protocols are there, already things are there. So how do they work? That only we are discussing. So what can you say? What are the applications of local area network? Abhishek Agarwal. Abhishek Agarwal, you are not there? Ehsan, what are the applications of local area network? Abhishek Agarwal.
Hello, Priyank. You please put everything on recording.
Okay, sir. Can you say Abhishek?
No, sir.
You can't say applications of local area network. Are you using any network? ये इतना देर तुम बंद करके कहाँ चले जाते हो माइक?
सर है सर सॉरी सर
सॉरी क्या वो उसमें ऐसे थोड़ी कि तुरंत तुम बंद करके गायब हो जाते हो. एप्लीकेशंस ऑफ लोकल.
When we need to transfer or communicate in locally, so we can use LAN, and it is faster, and we don't need data plan from
locally means.
So like in a building or within a few kilometers.
Okay, basically the main purpose of a local area network is to allow access of the shared resources, shared document, right? You can access your friend's computer from your place if both of you are connected in a LAN. So and access the shared material. Like the best example was a DC++. Earlier we had it in the net in the campus. I do not know whether it works now or not. DC++, like that was basically a shared everybody will share a minimum minimum amount of storage from their system, and it will be available for public. So you can access that. Everybody can access that. Whether like in our intranet also, you share. We share the nodes, right? We share these things. So that is basically main purpose is to allow sharing of documents, resources, right? आप अगर आपके घर में एक ही printer है and many persons are using, so you can say that if it is connected in LAN, many persons can use it, right? So coming with this concept that what is LAN and what are the applications of LAN, there are many such applications of LAN, whether it is related to the storage area network. You may not be knowing that earlier there were mainframes computers and others. So if the memory was only like the storage was only could be accessed through the main computer, right? But with the development in this electronics industry and the slashing of the price, now we have separate storage area networks, right? What about clouds? How many of you know about cloud? Can anyone say about the cloud storage? What is that, cloud storage? Yes, Abhinav. Abhinav, what is cloud storage?
Sir, in cloud storage, we can store our data without having any physical storage device such as pen drive or hardware.
So what I want to say that like whenever we are storing anything on the cloud, is there anyone sitting in between that we have to take always permission from him or her to access the cloud? It is not like that. Now anyone can access the cloud. There is a certain portion is of that cloud memory is cloud storage is dedicated, that how much you can access, right? Based on that you are allowed to do so. So similarly,
Yes,
so that is what an application of a local LAN kind of thing, where you have a storage area network. So anyone can access it, anyone can take the data, anyone can put the data. There are obviously there will be, it is not like that anyone can access anything. So there will be definitely, there will be authentication, there will be always like a reliability issue that no intruder should access anything. So that will always come in picture, right? So that there are many such examples, right? Like I have given a cloud storage area network or a cloud storage. Similarly, there can be many such examples. So I'm coming back to this topology part, right? So we discussed about the mass and bus, and the extended form of bus is called as a tree topology, right? So what is this tree topology? Can you say? You have seen the tree have branches, right? So there is a main cable, there are branches of the tree, okay? So there can be many branches as in a normal tree. So is in general it is like a bus, right? You can see it is like a bus, but it has multiple branches. The data travels only in one direction. In case of a tree, the data travels in this direction. There is a head end from where the cable starts, and at the end there are terminating resistances, just like in bus, right, which absorbs the data when it reaches at the end of the cable, right? So just because otherwise what will happen, it will result in unnecessary utilization of the resources. So once the data reaches at the end of this network, that is being removed from the network by these terminating resistances, right? So you can connect the nodes, many nodes can be connected, the trees can have many branches, right? So the data flow will be only in one direction, unlike in bus topology where the data flows in both the directions, right? And it is received by all the stations in both the directions in case of a bus topology, while in tree topology, the data flows only in one direction. So all the stations which are downward will receive this packet, right? So you can have many such branches, many such things. So tree topology is just a generalization of a bus topology. Otherwise, all other things are same except that the data flows only in one direction, right? So now coming to the star topology, as I asked you earlier in the first class, that which type of topology do we have in our hostels? Somebody said we have a star topology. So what is a star topology? Basically, in a star topology, we have a central hub. We say it as a hub. Hubs can be of different types. I will tell those things, that it can be a passive hub. Passive hub is simply a connector which simply connects the cable, and there can be an active hub or a repeater, you can say, right, which generally repeats the signal. So I suppose some signal is coming on this line. It will generally, if it is an active hub, it will simply repeat this. Yeah, because what is the function of a repeater? It simply regenerates the bit pattern on all the outgoing links except the incoming link, right? So so that is what the central hub means, right? What is the job of a central hub? Central hub means every node which wants to transmit will send the data first to the central hub. Suppose if there are stations A, B, C, D, E. So suppose A wants to send something to D. So it will first send it to the central hub, and this central hub, except on this incoming line, okay, it will pass on that bit pattern on all the outgoing links, right? So it again there is an issue that the reception will be received by all which are connected with this central hub, right? So this central hub can be a passive hub, where it is just like a, you can say, a connector, right? And it acts below the physical layer. And there is an active hub that is called as a, you can say it as a repeater, that acts at the physical layer. And there is a switch. When we replace this hub with a switching action, why a switching action is required? Anyone? What is a switching action? Ayush, Paul, what is a switching action and why do we require it?
Yes, sir.
What could be a switching action in this case?
Sir, could you please repeat?
I am asking, this is a star topology. In this, it can be it is written as central hub. So hub can be a passive hub, it can be an active hub, or it can be a switch, right? So in your hostel, which topology do you have?
Start.
Star topology. So every floor you have got a LAN switch.
Yes, sir.
So how do they work? Is it a LAN switch or a passive hub or an active hub? What is there in your hostel?
Sir, I am not sure about that. Which one do we have in hostel?
Okay, it is a LAN switch. Why a switch is required? Because as I told you that if it is a passive hub, it is simply a connector where these cables are just connected in a fashion that whatever transmission is coming, that will be passed on to the others, right? If it is an active hub, it is a repeater, so it will just regenerate the pattern on all the links except the incoming link. Whatever transmission is coming, suppose some transmission is coming from A that is intended for destination D. So if that transmission is coming from A, the central hub will take it and will send it in all the links, okay, from E also to D also to C also to B also, except on this line from which it is incoming. But the disadvantage is, similarly, first of all, the possibility of the collision cannot be avoided. As I said, that any shared medium, any shared access, whenever something is shared among nodes, there will always be a chance of conflict, right? Every node, maybe at the same time, two or three nodes may try to transmit and may result in a collision, right? First thing. Then second thing, that the transmission from a particular station to a particular station should not be received by all other stations, right? So there should be a mechanism that will control the flow, that will control the data transmission, so that it will not be received by unauthorized nodes. So for that, for both the two regions, we require some sort of a MAC protocol, right? So yesterday I told you about the MAC protocol, that is a medium access control. So that not only will govern access, that not only will allow the stations to access the medium in a fair manner, right? But also make sure that the two stations should not transmit at the same time, which may result in a collision of data, right? So if, as I told you yesterday also, that if collision occurs, the network get jammed. It doesn't clear the collision, because subsequently many collisions results, right? So just like I gave you an example of this expressway, that once an accident is taking place, that there are more chances that the vehicles coming from the backside may again rammed into those vehicles, right? So if they are coming in a high speed, if the so there is a more possibility. So once a collision occurs in the network, that may result in more number of collisions, right? So how this possibility can be avoided? So one of the thing is that we should replace it with a switch. This hub should be replaced with a switch. So what is the switching action? That if it is coming from A and it is only for D, so then it will simply pass from A to D. So how this switch will know that it is coming from A and it will go to D? I told you yesterday that there will be in the packet itself, there will be some control information. That control information will have the source address, destination address. So just by seeing this destination address, this switch will pass this packet from A to D. So now if we are using a switch, it will not go to all other unauthorized nodes. Moreover, it will also increase the throughput, because at the same time, when A is sending to D, B can send to C, C can send to E. So it will also increase the throughput, right? So replacing it with a switch can mitigate the possibility of collision, right? And will improve the throughput of the system, right? So this is about a star topology. Can you say the advantages and disadvantages of this topology?
For advantage that it is not broadcasting the data, it is sending to a particular node only, to point to
So
point.
that will be only the case when you are using a switch, right?
Yes.
That only will be possible when you are going for a switch. Otherwise, if it is a passive hub or an active hub, it will simply work like in that broadcast fashion, right? Any other advantage, disadvantage? Any
In case if any one of the system is not working, it does not affect the other systems.
but if the central hub itself fails, then
That will be the disadvantage, sir. Then
that will be the disadvantage, right?
yes, sir.
See, the main reason you should understand that the main reason that why you will find that why the star topology is widely deployed, right, in all the buildings. The main reason was that when can you say, I told you earlier also, but I do mention here that the main reason was earlier we had a all the buildings wired, all the office buildings were wired with this twisted pair, that is what the telephone cables, right? So the same telephone cables or the twisted pairs were utilized for this networking also. So that is the main reason of this star topology being so popular. Okay, uh, because the twisted pairs are cheap. Already buildings were wired, so the same infrastructure was utilized, and that is the main reason the star topology is mostly used in buildings, in your hostels, right, in office buildings, in your house. Because the layout is also like that, because every floor you will find one switch is there, right? That switch is connected with the other floor, right? So once you are sending the data, it will go to your floor, then it will pass on to the other. So there is a hierarchy in that. What is that hierarchy? You will find that there will be a hub, then there will be a header hub. So right, so you can have many such things. So you can have there can be many such hubs. Like this is what you are sending from ground floor to your ground floor switch. Then it will be passed to first floor switch, right? There can be other stations may be connected to this. So like that, this is what in a hierarchy fashion, like you have a hub, you can have an intermediate hubs, you can have a header hub. So like that, it can be arranged. So coming to this ring topology, right? Can you say what is the ring topology? You can from seeing this diagram, can you say? Anyone?
So one device can communicate only to maximum two devices. Right.
See, it is a ring.
Ring. Okay, so
Ring.
it can connect only to the front computer. Like if it is going clockwise, then it can communicate only to front computer only. And
Right,
if it wants to communicate to another, it will go passing all the computers.
You are not fully correct, but one thing you mentioned very correct, that it should be either it will work in a clockwise direction or in an anti-clockwise direction, right? The movement will be only in one direction, either in this way or the other way. See, what is the advantage of this? How the ring operates? Basically, you can see that there are 4 stations connected with in a ring topology. Sorry, 5 stations. So how does the ring work? Any station wants to transmit. Okay, first of all, those concerns will always be there, that who will transmit first, right? Suppose if it's a ring means it is connected in a ring. So again, as you mentioned, that either the data will move in a clockwise direction or in an anti-clockwise direction. So let us say in a clockwise direction. So station A wants to send something to D. right? A wants to send something to D. So it's simply, and I have assumed that A has got an access, right, over other stations. So A has got the privilege of accessing the network first. So in that way, if you see that A will send its data first to downward down the lane, right? So once it's passing on the data, it first reaches to B. So see, in a ring topology, each station is associated with a repeater, right? One repeater is associated with each station, right? So what happens then? The data comes, when this packet comes to B, this repeater scans all the bit pattern. It receives the packet, it passes to the station matches with the destination address and says that, okay, this is not for me. So then it regenerates the pattern on this side. Then it goes to the repeater of C. Repeater of C copies the frame, checks it whether it is intended for C or not. If it is not, it regenerates the frame once again on the link. Then it reaches D, where D copies the frame because it is intended for D. Then it regenerates the frame, and similarly E also performs the same thing. It copies the frame, checks whether it is for E or not, then it regenerates the frame. Now I have two questions to you. First of all, what will happen to this frame? Will it keep circulating in the network, or it will be removed from the LAN? And if it is to be removed, who will remove it? Who will answer?
But the receiving, like if A is sending to D and D receives the data, then it will be removed
So you mean to
by
say that
D.
it should be removed by D, right?
Yes, sir.
But you have studied all those things now: stop and wait, flow control techniques, different flow control techniques. There used to be an acknowledgement for everything, right? In a stop and wait, how does the stop and wait works? That once you send a packet, right, and till you receive an acknowledgement back, you are not allowed to send the next packet, right?
Yes,
It was like that. So it can be removed by the destination station, but what about if the source station, there can be many flows also in this. If you are saying by the destination station, suppose when you are transmitting in the network, there may be a possibility that the destination address itself gets corrupted, the frame gets corrupted, and the destination address, the destination is unable to recognize this frame. Then in that sense, it will keep circulating.
then if it reaches back to the same source and destination address is same, then that will be destroyed.
So the source should take the responsibility. If the source does it, there are two advantages. What are the advantages? That the source will know whether it is copied successfully by the destination or not. Right? Whether it is copied, how can it recognize that? Because when the D is copying a frame, it can alter some of the bits of the frame to mark that I have copied the frame. Right? I'll discuss it in detail, that there are some bits. Suppose this bit, D0 bit. If this D0 bit is 0, this D will make this bit 0. So that will say that the frame is copied. That you can say that it may happen in the network also, that this bit may get changed. That possibility cannot be denied. But generally, if we assume, so in that sense, so one particular pattern will be set by the destination, that if it copies the frame successfully, and the source will check that pattern and will recognize whether the frame is copied fully or there was some error in the frame. Because of that, the destination has not copied it, so it needs to retransmit the frame. right? So all those things. So the destination station is responsible for removing the frame. The advantage is that it will also serve an auto acknowledgement to the source that the frame has been successfully delivered at the destination, right? Now, is it clear? So in a ring topology, it provides, can you say the advantages and disadvantages of the ring topology? So, so if the next station wants a chance to transmit, once again there can be a conflict that who will transmit, right? So आपने सुना होगा there are different MAC protocols. In that you must have heard of token bus.
Yes, sir.
जैसे आप यहाँ पे हॉट एंड कोल्ड में जाते हो BIT में, it they give you one token, right? So once you, whoever has the token is allowed to take something, a coffee machine or whatever it is, you can take it from the coffee machine or coffee from the coffee machine if you have the token, right? So some sort of token is distributed. Okay, one token circulates in the ring, right? Then the priority and many things comes. Okay, that who will be having the priority. मान लो 5 स्टेशन है, किसको आप बोलोगे कि पहले टोकन कौन लेगा, right? So then there are many things comes. Then how long one person will hold a token? How long a station is allowed to hold a token for transmission? Then there are various types of stations also involved. That when you say that some of the stations will have a lot of data to send, but some of the stations will have very rarely will have data to send. So in such scenario, how a balance is made, right? Because there are two types of stations, we say there are two types of traffic, we say, right? We say a traffic which is time sensitive traffic and time insensitive. Okay, so can you say what is time? Can you give any example of a time sensitive traffic? Time sensitive traffic means if it is not received in time, it has no use. Batao? I can say it is a real-time traffic, real-time data, right? So if you are watching a movie online and if you are not getting it, okay, if suppose it's getting delayed or the packets getting delayed or the packets getting dropped, right? Will not be good for your application. So there is a time sensitive traffic, right? So if a station which supports a time sensitive traffic must be given a priority over the stations which supports only time insensitive traffic, or they are not generating that much traffic, that much data, right? So it depends how will you handle the stations, how will you deal with the priority of the stations, right? So there are many mechanisms for that. And time insensitive is an example is an email, right? So email is a time insensitive traffic which doesn't require that on online delivery. But suppose if you are doing a chat or you are watching a movie, you are downloading a file from the in a real-time manner, that application does get hampered using if your node is not allowed, right? So in a ring topology, the stations obviously they contend for access, so that can be taken care by a token that circulates in the ring, and whenever whoever grabs that token, how grabs, let us say first it is given to A, Then once the A completes its data transmission or it exhausts its time limit, it passes that token. So the downward station like B, because the token will also circulate, will also traverse in the ring in a clockwise fashion. So if it is traversing in the ring, so station B will grab it and will transfer its data. As I mentioned, either there will be an overhead on the maximum data transmission or over the time limit, right? So once any of the thing is exhausted, it has to leave the token, then the token will go to C, then from C to D, like that. The downward station will grab and finally the token will circulate in the ring in a clockwise direction. Now the question arises that who will, if suppose if C is having a high priority data that needs to be sent immediately, but it doesn't have the access to the token, then what will happen, right? So that is what I mentioned, that there are provisions, right, for to dealing with the time sensitive traffic or time sensitive traffic. We say elastic traffic and non-elastic traffic. There are many names that you can put. Elastic means that can adjust with time, right? Inelastic means that cannot bear the delay in the network, right? And if it will be useless if it is received after a certain period of time. So there can be so that is about the ring topology. Can anyone mention about the advantages and disadvantages of the ring? Anyone?
So for advantage, there will be no collision.
Right. The collision possibility, if you are saying about a token, right? If there is a token, then there is no possibility of collision. And
Yes, sir.
moreover, there is a dedicated link between each station, right? So you can see there is a point-to-point link. Point-to-point link means your data is secured as well as your data transfer will be faster. Dedicated link between stations will make your data transfer faster and secure, right? So this is the advantage of ring, because ring provides fair access to all the stations. Each station gets a fair access of the shared medium, and they perform data transfer. Can you say the disadvantage of the ring?
So if any one of the system is broken or something happens, the ring will break.
Right. If the cable is cut or anything, the whole communication will be stopped. Right. So that is the disadvantage of ring. So we will see more about these topologies now. And so you can see that as I said, hub, star topology, or ring topology. Okay, I will discuss it in the next class. Right.